Today I am going to explain some questions from the chapter Metals and Non-Metals. A reactivity series. Uh, Now I am just naming four metals: copper, lead, magnesium and silver. Listen me: copper, lead, magnesium and silver. Out of these four, which will displace zinc from its salt solution? Did you follow the question? The question is that out of four metals, copper, lead, magnesium and silver, which one will displace zinc from its salt solution? Can you name? So it is magnesium. So, okay. Magnesium is more reactive than zinc. Okay, that is why magnesium will replace zinc from its salt solution. The other three metals like copper, lead and silver, they are less reactive than zinc, so they cannot replace zinc from its salt solution. Okay. Now, next question. Now, iron, rod, and steels. So many types of steels are there. They are the very hard one. Stainless steel is one of them. Like that, there are so many kinds of steels are there now. Okay, stainless steel is stainless. It is here. It is non-corrosion, and some other steels are also there. So they are very much hard than stainless steel. Now, what makes iron hard and strong? The question is, what makes iron hard and strong? Okay, what makes iron hard and strong? And the answer is carbon makes iron hard and strong. Okay, carbon makes iron hard and strong. A little amount of carbon is added to iron to make different kinds of skill requirements is fulfilled by adding carbon. Right? One more thing here, tungsten can also make steel hard and strong. Tungsten also can make iron hard and strong. Right? So a small quantity of carbon is also present in stainless steel. Okay, the more carbon in iron makes it more hard, but even so, that is a limit. Beyond that, the iron becomes brittle. Okay, so what makes iron hard and strong? The answer is carbon. And tungsten also makes iron hard and strong. Now the next question. Now, what is amalgam? Okay, what is amalgam? What is amalgam? Amalgam is a alloy of a metal and what? And mercury. Any metal with mercury is called amalgam. That's right. Amalgam is an alloy of a metal, any metal, plus mercury. Mercury should be there. One of the metal is mercury. This is important. It's okay. Another metal can be also. Any other metal can be added plus one mercury. So amalgam is an alloy of a metal and mercury. It's okay. Now, next question is which is used to galvanize iron article? Galvanize iron articles. We might have heard about galvanized sheets. Iron sheets are available in the bazaar for roofing. For roofing purpose it is available in the bazaar. So what makes iron galvanize? And the answer is zinc. Okay, a small layer of zinc is coated on iron articles, and that makes it galvanize. And the next one question is, uh, there is a metal when exposed to iron, okay, form a black coating on it. Okay, black coating on it, and that is a very expensive metal. Okay, which is that? Can we name? A metal is there, which is a very expensive metal. It is now. So when exposed in air, it becomes a black, okay, coating on it. Which is that? Can we name? This is silver. Yes, this is silver. Silver, when exposed in air, it makes a black coating over it. It's correct. Now, next question. Listen me. Most metals oxides are insoluble in water. It's okay. Most metal oxides are insoluble in water, but some of these dissolve in water. Okay. What are these oxides and their solution in water called? Okay, did you understand the question? Most metal oxides are insoluble in water, but some of these dissolve in water. What are these oxides and their solutions of water called it is? And the answer is, solution of metals oxides of water, okay, is called alkali solution. Okay, alkali. Okay, for example, sodium hydroxide, potassium hydroxide, calcium hydroxide. So the oxides of these alkali metals, sodium, potassium are alkali metals, and calcium is alkaline metal. But the oxides of sodium, potassium, okay, in solution, in watery solution, the oxides of sodium and potassium, okay, when added to water, it becomes hydroxide, sodium hydroxide and potassium hydroxide. So they form alkali. They are known as alkali. That solution is known as alkali. They are the bases. And the bases which are soluble in water are known as alkali, Calcium is alkaline metal. It is the oxides of calcium is also soluble in water. Okay. Now the next question I am talking about is, now at ordinary temperature, the surface metals such as magnesium, aluminum, zinc, etc. is coated with thin layer. What is the composition of this layer? State its importance. Again, I am repeating the question. At ordinary temperature, the surface metals such as magnesium, aluminum, zinc, etc. is covered with thin layer. What is the composition of this layer? State its importance. It's okay. So the layer of oxide layer is known as, they form because oxygen is there in air. Oxygen is only one which is reactive is a reactive one. It is here nitrogen and carbon oxides. Nitrogen, okay, doesn't react, usually doesn't react. Carbon dioxide reacts very least. So oxygen reacts with metal to make some, metallic oxides. It makes the metal less reactive, it becomes passive, and makes it more useful because it cannot get corroded and remain as it is. This may be aluminum oxide or zinc oxide. Okay, we have seen at our home. When the surface of these two metals are clean, utensils made of these metals, metals, when they are clean, so they become tarnished, means there is black coating on it. After some time it is here, and that is oxides of metals. Is correct? Did it follow or not? So there is the oxides of metal. It is clear. Now the next question. Yes, importance is that okay, they prevent further corrosion of metals. But in case of iron, okay, this is not in case of iron. Iron, okay, corrodes, okay, from the core, means the whole iron can be corroded or can be rusted. It is here. So the layer of iron oxide doesn't prevent further corrosion, because that is, the iron oxide is flaky. It is here now. Okay, it is flaky. It allows oxygen to go inside. Iron oxide.